In the present video, we continue with showing you algebraic manipulation. Part 2 refers to the second set of commands in the, I'm gonna go down below here, in the simplify menu, and then you have factorials and gamma. This has to do with the gamma function. And so the gamma function let's say gamma of 2.3, and you do shift enter. It's a function that's available. It's an advanced mathematical function that is available. It does have the property that if the argument is an integer, let's say gamma of n is equal to n minus 1 factorial, you can check that by using simplify factorials and gamma, convert to factorials, and say gamma of n shift enter. And say, okay, yeah, gamma of n is equal to n minus 1 factorial. You can also use simplify factorials and gamma, convert to gamma. Let's convert factorial to gamma. And so if I say n plus 1 right arrow and I enter a shift exclamation mark, which is the factorial, shift enter, you get gamma of n plus 2. That's the only use of these two top commands. Then you have simplify factorials and combine factorials. I actually have some examples in here. I'm going to copy that and say simplify factorials and gamma simplify factorials. The function is called min factorial, like minimize factorials, and I'm going to delete that, do Control V. I have an extra parenthesis that I need to get rid of there. And now all parentheses here, and I do Shift Enter. And so it's saying n plus 2 factorial times n plus 1 factorial is equal to n plus 2 multiplied by n plus 1 factorial squared. So I simplify them a little bit. This could be useful in some mathematical applications related to, for example, polynomial expansions or something like that. If I go now to simplify factorials and gamma combine factorials, factcomb, the example I have for this one is n plus 2 factorial. I'm going to type it right, actually. N plus 2 factorial divided by n factorial. So parenthesis, n plus 2, sorry, 2, right arrow, of exclamation mark, slash n factorial. Shift enter. Didn't simplify much. Let me see if I get that right. Yes. Oh, actually this is still with min factorial. So I'm going to correct that here and type min factorial. This is another example of. So simplifying that gives you n plus 1 multiplied by n plus 2. I don't think I have an example for the very last one, which is the combine factorials. Anyway, we'll skip that one and then start with simplify trigonometric simplification. Simplify trigonometric. Now, the reference here is not trigonometric, but I do have examples of trigonometric here, and I have several of those. Sine square plus 2 cosine square. I'm going to copy that argument and paste it in here. Just shift enter, shift enter. It's simplifying to cosine square of x plus 1. The next example is another trig sim, so I'm just going to copy the whole command. Control C, Maxima, Control V, shift enter. Sorry, click on it, shift enter. That gives me sine square of a cosine square. The next example is a trig reduce, and so I'm going to copy the argument already. Sine of x over tangent of x, Control C, go here, go to simplify, go to trigonometric simplification, reduce trigonometric, and actually reduce this back to this thing, but that's not the one I want to simplify. Is this one. Shift enter. Sine of x over tan of x is equal to cosine of x. So some of these things are things that you remember very well. You probably don't need Maxima to do it for you, but it's available. Then do we have expand trigonometric, and for trigonometric expansion we have sine of 2x. That's simple to type. You're just gonna delete sine 2 times x, shift enter. 2 cosine x, then sine x. You could try also trig expand cosine of 2, and instead of using x I'm going to use theta, and that will give me the opportunity to use the Greek letters here, and do shift enter, cosine square of theta minus sine square of theta. Next, see in the next example, tangent of a plus b. Alright, I'm going to proceed here to simplify trigonometric, expand trigonometric, and replace the percentage symbol with the tangent, and instead of a and b I'm going to use alpha plus beta. Alright, if you do trig expand sine of x plus y, give you the formula of the sum of an angle and so on. So that's some example of trigonometric expansion. And then you have trigonometric rational. This example is exactly the same, so I'm just going to modify this with a square. So tangent square minus sec of, that's the very last one of my trigonometric simplification. That expand canonical form. Canonical form, and I'm going to say tangent of x square minus secant of x gives me that result. Now I'm going to copy this, Control C, Control V. No, didn't do it right. And let me just type delete here, trig rat tangent of x to the right square minus secant of x to the right square. That gives me minus 1. There's a trigonometric identity that says, that relates the tangent square with the secant square. And so these are the examples I want to show you for trigonometric. And then you have complex simplification, and it's convert to rectangular form. That's when you have a number, let's say 5 times exponential of parentheses percentage I times say percentage pi, that's how you enter pi here, over 6, for example. And so you do shift enter. This is the polar form of a complex number. This is the rectangular form. This is the real part. This is the imaginary part. Regarding real part and imaginary part, if I go to simplify complex simplification, get real part, the real part of the previous result is that one. If I go now simplify complex simplification, get the imaginary part. The imaginary part of this one is 0, but I believe that if you put a second percentage symbol, no, it doesn't work that way. Anyway, what I'm going to do is delete here, and I'm going to copy this thing, Control C, Control V, Shift Enter. There's a syntax error because of the parentheses here. They didn't come out correct. There's closing parentheses here, and I need an opening parenthesis, which means I need to delete the closing parentheses here, and now it works. So the imaginary part of that as well, and the real part, imaginary part are available, as I mentioned, in Simplify, Complex Simplification, get real part, get imaginary part. I'm going to do now convert to polar form. Simplify, Complex Simplification, convert to polar form, and I'm going to do Control B because Control V. I have a rectangular form, and so that's my polar form, and I have covered then the first 4. The Moev, it's about the same as polar form. If I'm gonna look at an example that I have here, the Moev exponential of minus I, So I'm going to go here and say simplify complex simplification, the Moev exponential of minus percentage I. Control Enter. That's cosine of 1 minus I sine of 1. That's basically the same as the convert to rectangular form. And then we have simplify complex simplification, exponentialize. Exponentialize means if you have, for example, the hyperbolic tangent of x, it can be written in terms of exponentials. And then another one that you can try here is say the tangent of x. It has somewhat similar expression, but this one involves imaginary exponents that this one doesn't. So a few things here. The percentage I, it's the imaginary unit. Percentage e is the exponential base of the exponential, and percentage pi is this. And so it will be represented like that. If I do say percentage e float, float that, give me the value of e. If I say percentage pi float of the previous one, gives me that number. So with that is the second part of the simplify menu that I have presented in here, and I want to finish my video for this second part.